Namaste and welcome to my channel. It's me Vishal Rainaji, P. Robusta. In this tutorial, I will visualize the forest canopy height for Tha municipality, Nepal in both 2D and 3D using R. Here, I will use open data and a powerful R package and end with a high quality annotated map. Let's start it. First, we set the working directory where all our files and outputs will be saved. For this, Control Enter. I have created a 3D Forest CHM folder in my desktop. Then I will install the packages called Pacman. I have already installed, so I don't want to install right now. So I comment out it here. Now we will load the all necessary packages, including spatial data handling, downloading files, canopy height data, plotting, and image editing. For this, we will use Pacman. SF for shape file data handling, HDR for downloading data, Forestdata package for downloading canopy height data, ggplot2 for data visualization, raster for raster processing, shader for 3D visualization, magic for annotated map. Now we will download the administrative file. For this we will go through open data Nepal. Now we will assign a zip path. Now using download.file, we download the zip file from the URL and save it locally. We also print a confirmation message. To see what's inside the zip, we list its contents without extracting it and print the file name. Now we will extract all files into a folder called local unit and make confirmation. Now we look for all save files inside the folder extracted. Now we will read and load the save file from the extracted folder. Then we will check the CRS of the save file. As our coordinate system is in Nepal, DD, Everest, Bangladesh, now we will transform the data into the standard geographic coordinate system WGS84 EPSG 4326. Now we will plot and visualize the map. The map has been plotted in the plot section. Now we apply filter to extract the area of interest, that is Tha municipality, from the local unit data. Now we'll print the filter data to confirm the correct municipality has been selected or not. Here is the given is here Tha Nagarpalika, Bagmati province, and it is the selected as we have filtered. Now we'll plot the boundary of Tha municipality and check its CRS again. And here is the plot of Tha municipality boundary. Again, I will check the CRS of the Tha municipality. And this is here the in WGS84. Now we will download the Forest Canopy Height Model. For this, we will use the Forest Data package to download the Canopy Height Model for Tha municipality, and then we will crop and marks into the Tha municipality boundary. I will choose meta here because it is in 1 meter resolution. Either you can use the ETH, which is in 10 meter resolution. Layer equal to Canopy Height Model CHM. Now we'll use crop. Crop is equal to true. Max is equal to true. Merge is equal to true for the different tiles to take into a single one. Now we will run this and it will take some times depending upon the internet speed. Now we have to check the others data too. To use the data, we will need to cite this by using this. Now we will check the class of the downloaded Canopy Height data. Okay, this is the spectrasta attributed package, Terra package. Now we will convert the Canopy Height model to a raster object for further processing. And now we reproject this raster to match the CRS of the area of interest, that is Tha shapefile, ensuring the spatial alignment. For this, now we will aggregate this raster data by 5 to reduce the resolution and speed of the processing. For this, we will use here fact equal to 5. You can use other values also, 5, and function equal to mean. This will also take a bit time. Now we will convert the aggregated raster to a data frame with XY coordinate and canopy height values. Then remove any missing data. For this, now we will rename the data frame here. And now we will remove the missing values here. Now we will look at the summary statistic to check the range of the canopy heights. For this, and here is the minimum, first quantile, median, mean, third quantile, and maximum height. Now we will plot the aggregated raster directly to visualize the canopy height in 2D. For this, here is the aggregated canopy height model of Thaha. Now to classify the canopy height into categories, we will find the minimum and maximum canopy height values from the data frame. For this is not necessary as we have already calculated the maximum and minimum values, but I will continue this. We will print here, and the minimum is the 0, and oh sorry, and maximum is the 36.30518. Now we will break into 4 class range from 0 to 36 meter and create a color palette to use the map for visualizing height difference. For this, I have break into 4 classes, but we can use different classes for here, and also we will assign the colors as per the classes. Comma, this is the HTML color code. and we will assign texture, color ramp palette. We start by initializing a ggplot object called p using our Canopy Height data frame as the data source. And we will use geom tile to plot each pixel as a square tile positioned by x and y coordinate and fill with a color representing the canopy height. Next, we overlay the Tha municipality boundary using geom ASAP. The polygon is filled transparent and the boundary is outlined in a black with a line thickness of 1. Now, we'll define the color scale for the tiles. The legend title is set to height in meter and color conforms are the custom texture palette colors and break on the legend are rounded canopy height categories reversed to the display in descending values. Now we will customize the legend guide for the fill color, vertical orientation, key sized, title above the key center horizontally, labels to the right and center only in the column. Then we will set the plot theme to minimal for a clean, uncluttered background. Finally, we print the plot object P to render the canopy height map. For this, now we will run this part of the code. It will take some time to render the image. Now we will save the 2D canopy height map at high resolution PNG file. For this, and here is the plot, 2D plot. Now we will create the 3D visualization using ray shader. For this, we will define the width and height for the 3D render image. Now we will pass our ggplot object to ray shader to create 3D plot. Here scale will increase the vertical exaggeration. Now we will run the ray shader code. It will open another window. Here is the RGL window where we can visualize the 3D map. Now, to export a high quality 3D image with advanced lighting, we will download an HDR environment file to add realistic lighting effect to render the image. For HDR image, we will go to the polyable.org and copy the download link. And this will download the image. Image is downloading here. Now we will render a high quality 3D image with the downloaded HDR lighting environment and saving it in our working directory. For this, reset and render high quality. We can, it will take time, and here is that file. Now we will load the rendered 3D image into Magic for annotation. For this, now we will define fonts, color, text size for the annotation. Now we will run this code. Then we add a large title at the top of the image for this. This section is for the title, and we will add the author names and other details at the bottom of the image for this. And we will run this code again. Now we will add the data source and citation just below the author annotation for this. For the data citation is already in the previous running. We will use this. And we will again run this code. Now we will resize the annotated image to a high resolution suitable for printing. Now we will score. That's it. It has been completed. Let's. Here is the final forest canopy height of Tha municipality in Nepal.